So now let's try to wrap our heads around this concept of a two-stroke engine. We went through the four-stroke engine. We talked about how we had this stroke and cycle kind of thing going on. And remember, there's four functions or four cycles that have to happen to make an engine work properly. We got to have an intake, we got to get gas into the engine, we got to compress that gas, then we have to, after ignite it, we have to have an expansion of that gas to get the power out of it, and then somehow we have to get rid of the exhaust. And we talked about on that four-stroke engine that those were a one-to-one with every stroke of the piston. Piston come down, intake, up compression, down for power, and up for exhaust. So it was a one-to-one. Well, now when we go to two-stroke engines, we're going to see it's no longer a one-to-one. We're actually going to combine some functions or some cycles on a particular stroke of that piston. So let's take a look at it. And with the animation here, you can see how that piston is going up and down. And there's a lot of things going on, but one of the things that I want you to think about and realize right away, now this chamber, this area underneath the piston, around the crankshaft and everything, it becomes much more critical in a two-stroke engine than it does in a four-stroke engine. So in a two-stroke engine, again, a couple things are happening all at the same time. So let's start at the top here. So if we look over at this static shot, we can see that when we're at the top, that fuel is compressed in there. We've already got the fuel in there. It's compressed. We ignite it. Now we start to get this power stroke, and it starts coming down. So we move over here where that piston is coming down. So let's watch what happens. If this was the piston, I'm going to cover up part of that. As that piston comes down, we have that fuel in there, the high pressure fuel that's pushing. Look what happens over here on the right-hand side. As that piston is coming down, I'm actually going to open up a hole. And that's where my exhaust gas can get out. So while the piston is coming down on the power stroke, toward the bottom of the power stroke, I open up the exhaust port. That high pressure gas, that high pressure exhaust in there can start to sneak out. Oh, and we kind of see that over here on this animation. As that piston is coming down, we see that exhaust gas start to sneak out over on the right-hand side. Okay, so now let's go back here. As that piston keeps coming down, we've opened up that exhaust port. Now if it goes a little bit more, we open up that intake port. And this is where the clean gas of the air-fuel mixture can come in. Well, how does it come in? Remember I said it was very critical. This area underneath the piston is really critical. So as that piston is going up and we're compressing that air-to-fuel mixture in the top of that piston up there, that's also bringing a negative pressure in here. So what happens is we're actually sucking some air-fuel mixture into this area underneath the piston. Okay, so over on this animation, we see over here this little flapper valve, a little check valve that's allowing that to happen. So as that piston comes up, we see this air-fuel mixture coming into this area down here. Now, as the piston comes down, it's going to open up this port over here. As the piston's coming down, it pressurizes it just a little bit. So this air-fuel mixture underneath the piston is under a little bit of pressure. When this port opens up, that's going to want to pop this air-fuel mixture up into the combustion chamber up here. So this pressure on the bottom forces that to go up into the combustion chamber. So we've got a lot of things happening all at the same time. So as this piston is coming down, we're letting the exhaust gas out, and we're also allowing the fresh gas to come in. So there's kind of the clean gas is kind of pushing the exhaust gas out of the combustion chamber. So a lot of things happen at the same time. Okay, so again, two strokes. Now think about how much power it has. Remember we talked about the bicycle analogy on a four-stroke engine. It's like only pedaling every other time. So we pedal once, we don't push the next time. Then we push, and then we don't push. Look what's happening on here. How many rotations? One rotation where I come down with the power, the exhaust, and the intake, more intake as it starts back up, and then it compresses, and then another power stroke. So on every revolution of that crankshaft, I get a power stroke. So that's going back to my bicycle. That's like we would normally do on a bicycle. We push every time that we come around, we're actually pushing. So we're going to get a little bit more power potentially get a little bit more power out of a two-stroke engine, okay? But what are the problems with this? And we're going to list these out here in just a second on the next slide. But let's think about this. As this exhaust gas is leaving over here and the intake gas is coming in, is that going to be a clean exchange? Probably not. So as that exhaust gas is coming out and the intake gases is coming in, there's going to be a little bit of mixing in between. So I'm either A, going to have some of the clean gas, air fuel mixture going out with the exhaust, which means unburnt fuel then is going out of the exhaust, or I'm going to leave some of that exhaust gas in that chamber there. So both of those things could be bad, could cause me some problems. So that could mean some not clean burning. So if I've got exhaust gas in there, it may not burn as cleanly. If I've got air fuel mixture going out, then it's not going to be, again, I've got some stuff going out the exhaust that I don't want going out the exhaust. So now I've got some emission problems. And that's one of the fundamental drawbacks of a two-stroke engine is this idea of that we've got some emission problems or potential emission problems in there. The other thing that goes on with this is that because this is an air-fuel mixture in this chamber underneath the piston, I've got to have lubrication in there. So if I go back to my four-stroke engine, that four-stroke engine, I'm going to put oil in there, lubricating oil, and just let it lubricate. I can't put oil in here. So what do? I actually mix some lubricating oil with the gasoline or with the fuel as it's coming in. So this is a air-fuel mixture in here, but there's also a little bit of lubricating oil. Guess what? That lubricating oil is going to go up in here and get burnt. What happens when we burn oil? It makes smoke. And so we've got some more emissions issues out there. So those are kind of the trade-offs. So let's kind of list some of that out and think about two-stroke versus four-stroke engines if we look at them. So first of all, with the two-stroke, and what we'll focus on the two-stroke is kind of the differences here. 1 power cycle per revolution of the crank. That's a good thing, okay? So I get a little bit more power out of them. We talk about them being more power dense because of that, okay? Because, and really 2 reasons. So we get 1 power cycle per crank revolution, and it's a similar engine. So remember on that 4-stroke engine, we had to have valves and camshafts, and we'll look at all this equipment later to be able to open up and let the gases come in and out and all that. Down here, there's no valves. It's just ports that I'm opening and closing down there. So it becomes, in general, a much, much simpler engine. So that's one of the nice things about the two-stroke. It's a simpler engine, means it's a lighter engine, and I get 1 power stroke for every revolution of the crank, so I can get more power out of it, so they can be more power dense. This is why you see two-stroke engines in like performance motorcycles, so competition motorcycles. I can have a light motorcycle and be able to get a little bit more power out of it. In a performance setting, emissions, okay, I can deal with some emissions. You see a lot of these in small gas engines like in chainsaws and weed eaters, string trimmers and stuff like that, because one of the other things is I can turn this engine upside down. It works in all different orientations. This one may or may not, because if I get this oil up against this piston up here, it may cause me problems if that engine's not designed correctly. So those are some things that I have to be thinking about. So again, it can be more power dense. I can get some more power out of it. So that's one of the good things, or one of the differences between a two-stroke and four-stroke. They can be used upside down, but I have to mix my gas with a two-stroke engine. I've got to put some lubricating oil with that fuel. So that fuel has to have the lubricating stuff in it as it goes through. And because of that, because I'm burning that lubricating oil, that's going to mean my exhaust is going to be a lot dirtier. So I'm going to have some carbon buildup in there from burning that oil, which means my spark plugs, when I have spark plugs in there, they tend to foul more often. I'm going to have that incomplete gas exchange when I've got that intake, that intake fuel coming in, trying to push that exhaust out, and they mix in the middle. So I've got that incomplete exhaust exchange. So that gives me a lot more emissions and can reduce power if that's not done correctly. Now, there's a lot of different engine design things that engineers will do to try to improve that, and so we can actually make some of those engines fairly clean, but that still can be an issue with a two-stroke engine, and so that's one of the drawbacks to it. So when we're thinking about comparing two strokes to four strokes, there's some reasons why we might like the two-stroke and the four-stroke, but the reason that the four-stroke is more common in most of our vehicles and everything like that is primarily because of emissions. And you see a lot of regulations, like in California and places like that, where they actually prevent the sale of two-stroke engines, and so manufacturers have to design four-stroke engines for the typical applications like string trimmers and chainsaws and stuff like that for sale in some of those markets where emissions are a little bit more critical for them. So that's two-stroke engines, four-stroke engines, the difference between those, trying to get our head wrapped around how they work. Again, there's always four basic functions that have to happen. So that compression, the power, the exhaust, and the intake. So those four functions have to happen. On a four-stroke engine, that's a 1-to-1. Each one of those functions happens on one stroke on that engine. On a two-stroke engine, we kind of combine them. And so a couple things are happening on each stroke as it goes up and down. So there you go. That's two-stroke engines.